So now that we understand what is mass, it's time to understand how do we measure mass, right? So measurement of mass is pretty easy, as I just explained in the previous video, that mass is always the product of the density of something and the volume that that thing is occupying, right? So for example, I can just draw a block here, and then we know that what is density, the closeness of the particles, how close the particles that are there inside the box, that actually the box is constituted of. So the closer that they are, the closer they are to each other, the denser the block would be, right? So once, if we are able to simply understand the density of something or calculate the density of something, then we can also calculate the volume that of that thing, and then take the product of these two things and be able to calculate the mass of that thing. And how do we calculate volume is pretty simple. For different figures, you can have different techniques. For example, for a cube, you can just measure the length of one side of that cube and then take a cube of it simply. Or for a cuboid, you can just take, the product of all the three dimensions of that box or a cuboid, and then you're simply able to calculate the volume. And similarly for sphere, you have a formula to calculate the volume for a sphere, and for a pyramid, you have a separate formula. So calculating volume is no issue for a student of mathematics. Then you just simply calculate the density and take the product of that, and you're simply able to calculate the mass of that thing. Another technique would be to actually use the Newton's second law, which is force that is applied on anything should always be equal to the product of mass of that thing, right, into the acceleration product with the acceleration of that thing, that how that thing is accelerating, at what rate that thing is changing its velocity. If you're able to calculate that rate of change of velocity of that thing, and simply you can just make mass the subject in this equation. If you know the force that you applied on that thing, and then you just simply divide with the acceleration of that thing, and you're simply able to calculate the mass of that thing. A simple example of Newton's second law that we can use generally in our daily life is that if you want to calculate the mass of something, we know that the force by which something is pulling anything is also a force. In this case, for example, you can just hang a ball in the air, and then we know that the force of gravity is acting on that thing. So if you know the amount of force that is applied on that ball, you can use a Newton meter in order to check the amount of force that the earth is pulling that ball with. And if you're simply able to calculate the acceleration of that ball, right, you can just divide that the weight of that ball with the acceleration that the ball is falling with, and you're simply able to calculate the mass. In this case, by experiment, we know that everything that falls, given that the air resistance is negligible, everything falls with an acceleration of around 10 meters per second square, right? So this is not the precise figure, but you can just use this in order to calculate the mass of something. And the weight of that thing could be obtained by just hanging it with a Newton meter, and you get the weight. And then you simply divide that weight with 10, and you get the mass of that thing. There could be other techniques, but these two are the basic techniques that you could be using in order to calculate the mass of something.